Right, so far in the stats class, we've had a lot of review. I know we talked about the different types of level of measurement, and that kind of stuff was probably new. But so far in this chapter, it's been mean, median, mode, and graphs and all that stuff. So it's been stuff that we've seen before. Some of today will be stuff that you've seen before as well. But then we're going to start getting towards variation and start really getting towards what's called standard deviation, which is going to be huge for the rest of the year. So we have to make sure that everybody understands what that calculation is doing. But before we get to that, we'll talk, and variation just means how can the data vary, okay, is really where that comes from. Variation, vary, right? How does it differ, right? Range is something that you've seen a lot before. And in fact, you could probably write the definition before I even get that off of there. It's basically the difference between the max and min entries in a set. So if I look at two different sets of data, the ranges could be very different, okay? One could have a range of 10 and the other one could have a range of 30, and so that would be one way that data sets could vary, right? They could be different. Okay. So here we have a corporation of hired 10 graduates apparently. The starting salaries for each are as follows, and please note that they're not making $41. It's $41,000 would be the first one, right? So when we're calculating these things, do we have to throw those other zeros back in? For example, for this first one, do we have to put 41,000 and 38,000 and 39,000, or can we do the calculations as they are here and just remember that when we give our answer? Which way do you think it is? Yeah, we can just remember it, right? It's going to be, because if they all have the same 3 zeros after it, it's going to end up the same anyway, so we don't have to worry too much about that. So what do we got here for well, which one do we want to do first? The minimum. Well, let's start with that. The minimum. Well, let's take a look. It looks as though, what's our smallest here? 37, right? Right there. So it's 30. So the minimum, and I'll just kind of write it there, is 37,000, right? And you can put the dollar sign on there if you want. And then our maximum, maybe I'll put it right here. 47. Yeah, I don't see any bigger. So 47,000. And probably range would be the easiest one to do next, right? So range, according to up there, says to take the difference, again, difference is the solution to a subtraction problem, between the max and min. So for range, we would take the max, which is 47. And again, you can just use the 47 minus the 37, right? You don't have to always write all those zeros, and we know the answer then is 10, right? So 10,000. And you may hear some commotion, and that's just people getting calculators to get the mean. And actually, one of it was just one person having a piece of candy. So the mean. Again, mean is sometimes calculated a little bit differently than what's taught in here, but we're taught to add them up. Again, for calculating the mean, do we have to put all the zeros on it? No, we can just add them up as we have right here, and then divide by what we have. In some cases, for the mean, you are told to take the max value and the min value, add those together and divide by 2, and a lot of times it's very close. But the way we're going to calculate it, we're just going to add them all up and divide by the 10. Hopefully there's 10 there, right? Because it told us there was. And just looking at the data, hopefully you could get a guess going, right, about where it should be. Because hopefully if you get an answer of 80,000 to this one, you know that's wrong. Right? And what did you get for your total? Does anybody have that one written down somewhere? Yeah. Okay, that was your mean. Okay, the mean I heard here was 41,500. Okay, so what was the total you had? Like, what's the sum of all these? Does anybody have that number somewhere? 415,000. So then you divided by 10. Okay, or in other words, you had, well, basically for your answer, 415 was the total you came up with, right? And divide by 10, and then you can just move things over, right? And so we end up with basically that, knocking that off, right? And so 41,500, right? Nice thing with tens, they work really nice. Okay. Is that believable with the data? Yeah, I would go there. So pretty easy start off, right? Not too bad. Done all this stuff before. All right, well, here we go. Here's the new one. Ooh, where'd my definition go? There should be a definition somewhere. Is it down here, maybe? Ooh, I'm missing it. That's not good. I believe you have deviation written on yours. Is the definition just written on yours or no? No, deviation is not? Okay, well, I'll write it on here somewhere. Or is it on my next page, maybe? Nope. Oh, well. Make do with what we've got. Deviation. Okay. Here they call it the difference between an entry oh, it's right there. Found it. That was weird. All right. Deviation, the difference between an entry and the mean, again, mu of the data. We can get rid of that then. I thought it was weird that I didn't have it in there. That was rather bizarre. And this should be an entry. Right. So in other words, it's just x minus mu. That's deviation. You've probably heard the word deviate before, right? Maybe like deviate from a plan, right? So maybe you've already heard that phrase. It means kind of go away from or make a different plan, right? Right? So we're going to start with just deviation. And so if we take those salaries that we had earlier, we know the sum is 415. Right? Did any of you actually just look down there and see that the total was 415? Or no? No? Yeah. And then we're actually going to just find out, well, what is the difference? Well, what did you find out what the mean was? You found out the mean was 41.5. Now, they're calling that mu in this case. Do you believe that to be true? Well, for that company, it probably is. If those are the 10, could be, right? The 10 graduates, or you could call it X bar. Really, it doesn't matter all that much, but we're going to call it mu for now. So this deviation is basically saying this very first one is to take X, which happens to be 41 in this first case, and subtract mu, which is 41.5. Agreed? That's what it's saying to do in this column right here. Because we found the mean earlier was, this is mu. Here's a particular entry, right? So that deviation is negative half, right? And so for this next one, what we would do is we would take that particular entry, which is 38, and subtract it from the mean. Oh, I almost wrote mu there. Subtract 41.5. And I'm guessing we can all handle this calculation, right? So let's just show you the answers. No need to hide it anymore. What do you notice about these numbers? Well, they all happen to have a half in it, but that's just because the half was in the mean, right? But some are positive, and some are negative. And you notice at the very bottom of that, the sum of that deviation is 0. Should that happen every time? Well, isn't this kind of a waste of time then? Why would we find this if we know the total is always going to be 0 every time? Isn't that what the mean is supposed to do? It's supposed to make the total deviation of all of them 0? That's really what you never thought of it that way, but that's what it's supposed to do. If you calculated it right, that's going to happen every time. Seems like a slight waste of time, but it's not, because of what we're going to do with it next. Okay? So is everybody good with what we did there? How to find, this is called deviation. How much did it deviate from the mean is what we're going to talk about here. Okay. Everybody good? Okay. And I will talk in a little while why we use the mean and not the median, if we have time today. So now for today we're going to talk about population variance. So how does it vary? We learned how it deviated, but how does it vary? Well, what we're going to do there, we're going to find the mean, or the average, of the squares of the deviation. Because let's face it, if I find the average of just the deviation, that's not going to help me very much because I already know the sum is 0. So if I divide by anything, it's still going to be 0, right? So I'm not just going to sum the deviation. I'm actually going to sum the square of the deviation. Once you're done writing, I'll see if anybody has an idea of why we would square them. And if you want to flip back and look at the data, why would we take the time to square them? What does that accomplish? Yes? Yeah, it makes all the negatives positive, doesn't it? Right? If we go back, if I square all of these values right here, they are then all positive numbers, correct? Now, I know that some of you are thinking, why not just take the absolute value of them, correct? Wouldn't that also make them all positive? Okay. The reason is that absolute value is actually finding median, is what you would find there. And unfortunately, median sometimes, when you do absolute difference, that's what that would be, an absolute value, absolute difference, we can get more than one answer. And we don't want more than one answer. Okay? And I can show you an example later that would show that to you, that we can get multiple answers if you'd like. So really, that's the two ways of getting rid of negatives, right? Absolute value and squaring. It's your two main options. We're choosing squaring, okay, to get rid of it, okay? So that's called variance, okay? And if it's the population, I could probably give you the symbol. So population variance, this is, believe it or not, that is another version of sigma. It's kind of like, it's basically one of these looking things, all right? Okay. That's lowercase, okay? And so it's that squared because we took the mean and we squared it. And again, seeing this is the population, do you notice a capital N down there? Because we know it's the population. And we're going to sum those squares. So once again, when you look at these formulas, I hope you're thinking to yourself, I need to make that right there a column somewhere then, so that I can actually add them up, right, in your distribution. I have to somehow make that a column. So then I can turn around and add it up. Okay. Here's the big one, standard deviation. So earlier we talked about just deviation, correct, from the mean, but when we added them all up, we got 0. So that was worthless. So now we squared them, added them up, and divided by how many I had, right? So how can I get back to a deviation then? I just squared it, added them all up, and divided by it. So how can I basically take away that squaring I just did? What's the way to square root it? Okay. Now it seems, again, like a waste of time, but it gets us back, instead of being a sum of 0, it gets us back to something that's not 0. Okay. And as we go through the next chapter or two, standard deviation will become more clear and clear as we go. Okay. And not surprising, it is just sigma, or you take the square root of sigma squared, right? That's what it means. So you just take the square root of what we had up above. And yes, I am going to make you do some of these by hand, and then we will show you how the calculators will do this quite quickly. And standard deviation is going to lead us to that bell-shaped curve or normal distribution, okay, that gets talked about by another teacher here. Everybody good? Well, let's actually go calculate one of these darn things then. So I believe I've given you that on the back, correct? You have this information on there already? Which probably makes you mad that you wrote it down on the front, but here it is. So there's your regular deviation. If I sum it up, does it tell me anything? Not really. It tells me it's 0. So if I take the average of that, 0 divided by how many I had, it gives me 0. Not helpful at all. So what we're going to do is we're actually going to turn around, we're going to square that number. So here is, the deviation. Let's square the deviation. Okay? And obviously if we square a half, we get a quarter, right? And if we, and let's face it, we could all handle these calculations, right? So should we just move it over so you can write them down? Because I'm sure if I gave you calculators, you could do it all, right? And as you mentioned, all the values are now positive. Some much larger, perhaps, than you had anticipated. Okay. Was your calculator not working? Yeah. Oh, okay. Operator error, I've been told. So we notice for a salary of 38, the squared deviation is 12.25. For a salary of 44, we see that it's the squared deviation is 6.25. For 42, it's 0.25. This time, though, when I add them up, I'm not going to get 0. So I'm actually going to have something I can calculate. And yes, if I did the absolute difference, okay, or did the absolute value on there, that would also give me a value. But unfortunately, sometimes it could give me more than one answer. Because our final goal is going to be to try and kind of find a minimum. What'd you get for your sum of your squared deviations? This is what I got. 88.5? Is that what you got? Okay. So right now that number means nothing to you, and I understand that. Okay. It will mean a lot as time goes on. So now what I have to do is I have to find the average. So what I'm doing basically is finding out how much does each data, kind of on average, how much does this data vary from the mean? That's what I'm going to try and find out. On average, how much does it vary? Okay. Do you think these vary a lot? I'd say probably 47 has the biggest deviation, right, at 5.5. So does that vary quite a bit? Yeah. Mm-hmm. And how about the 39? Not so bad. The 41 doesn't vary much at all, does it? So what we're trying to find out is, in the end, how much on average do they vary is what I'm trying to find out. Okay. So variance, as we learned earlier, is basically the sum of those squares divided by n. So my variance is 8.85. Okay. But that's basically the average squared deviation, right? That's really what that is. But I don't want it to be squared. Okay. And that's where standard deviation comes in. I want to find out, on average, how much does each data entry vary from the mean. And so to get that, we will do one last calculation. But we have almost all the information. This last calculation is quite easy. Once you get to variance, standard deviation is quite simple. What do? Because this is this average of the squared deviation. I want just regular. You take the square root. Yeah, I don't want squared deviation. I want so here I got approximately 2.97, so approximately 3. And trust me, just taking the absolute value of all these numbers in this column and taking the average of that, would that be a whole lot quicker? Just taking the absolute value and taking the average of that one I circled in red, way faster, agreed? A lot less work. The problem is it runs into problems later, and that's why we do not do that. Okay. Okay. So a recap of what we did is we found what the deviation was. How much did it deviate from the mean? When we added that up, we got 0 because that's what the mean is. It's going to be that average number, and so they should deviate as a total of 0 from the mean, because some will be negative, some will be positive. We had two methods of getting rid of the negative. Absolute value, which would have been absolute difference, or squaring it, which is squared difference. Okay. Absolute difference, I totally agree with you, would be so much faster, be so much less work. But in the end, it does not necessarily give me the right answer all the time that we're looking for. Because sometimes it's like a median, it could give you more than one answer. Okay? Where here, if you square it, that's our other way of getting rid of it. So then I average all of that. I average the squared difference, right? And then I take the square root to get it back to just a deviation. And would you agree, if you look back here, about 3 would be the average of those red circled if they were all positive? About, right? If I were to average them, okay? So I don't know why there's another page, so I'm going to check it out. Oh, it's blank. All right. But think back to, and I know in this particular class everybody has had advanced math, and I don't know everybody listening to the recording will, but do you remember like x plus or minus some value? We'll call it a constant squared. That's just a parabola moved, correct? Perhaps up, down, whatever. So it's just a parabola, right? Opens up. Do you agree this parabola has one minimum for sure? I can minimize it, correct? I can find a minimum. How about this one? So there's your squared sum or difference, right? How about your absolute sum or difference? We didn't have a whole lot of these, but what does that look like? Who remembers what that absolute value graph, what does that look like? Anybody remember? Nope, wasn't that one. Nope. Not the steps. Nope. I think we've talked about everyone but the one that I won. Right? It's that one. But the problem with that one is sometimes, now you're saying, well, that could be minimized. Sure, sometimes. But look at the behavior near it. It's fairly radical, isn't it? Compared to this is very gentle. And the only problem over here is this one can do that. How many minimums do I have now? Is that easy to minimize? To pick just one? I can't just pick one, can I? This graph over here can't do that. You have a minimum every time. And our goal in the end is going to be to minimize that standard deviation. Is it easier to minimize a parabola or that V-shaped looking thing? And it's much more predictable to minimize a parabola. Is it more work? Unfortunately, yes. I'm sorry. It just is. Okay? Before we stop, I want to make sure that this number at least means something to you before we leave this page. That is called a standard deviation, and it's basically an average of those numbers, or how much they deviate, whether it deviates to the right or to the left of that mean, or above or below that mean. On average, that's how far my data set deviated from the mean. So did it deviate really all that much on average? Only 3? It really didn't deviate that much at all, right? We had one kind of oddball there, right, that deviated quite a bit from the rest of them, right? But for the most part, did they stay pretty close to the mean? Yeah. So now, what do you think would happen if I were to add, maybe they were really after a graduate, okay? And instead of this 47, they paid them 67. This will truly tell me if you understand what deviation is. Would that 2.7, if I did all these calculations over, would the standard deviation number go up or down? What would happen if all of a sudden, this one person got 67,000 over all these other people? I don't actually want you to calculate. I just want a general idea. What would happen to this average deviation then down here? Would it go up or would it go down? It would actually go up, in this case, a lot, right? Because this number would go up a lot, meaning the average of all those numbers would go up a lot. Would the median of those numbers go up a lot? No, it would stay fairly similar, right? So now can you see another reason why maybe an absolute difference or a median difference is not as helpful? Okay. So now what if then, what number could I change that to then to actually make this 2.7 number go down? If we actually ran through and did the calculations, what could I do? What number could I put in there in place of the 47 that would actually make the number go down? Yeah, anything. Or just put that 41.5 in there, the actual mean, right? That would really make it come down, wouldn't it? Because how much does that deviate from the mean? Well, it doesn't, right? Obviously, if I change these values, does the mean change as well? It does. But realize if I bring it down closer to a middle value, like a 42, that would change my mean a little bit, but it's not going to vary as much. It's not going to deviate as much. Okay, those words starting to sink in a little bit, maybe? Okay. Any questions? Hopefully that was helpful.